Today, we're going to pull back the curtain on something you do, oh, I don't know, hundreds of times a day. A single, simple click. We're going to follow its incredible secret journey.
You know that feeling, right? You click a link and poof, the web page just appears. It feels totally instant. But what if I told you that in that tiny, tiny gap, we're talking milliseconds, an entire journey unfolds?
I mean, it really does feel like magic, but it's not. It's this incredibly fine-tuned, super high-speed journey across a massive global network. So, what do you say? Let's follow that journey step by step. Okay, so before you go on any trip, what's the first thing you do? You pack, right? Well, your data is no different. So our first stop is seeing how your simple request gets all packed up and ready for its trip across the internet. And honestly, the best way to get our heads around this is to think about it like mailing a package. It's a really simple analogy, but it's going to be our guide through this whole thing. And trust me, it makes all the complicated stuff surprisingly clear. So picture this. We're basically just adding a bunch of labels to our package. Each step adds a new layer, a new label. Step 1, your browser writes the letter itself. That's the actual request for the website. Then you got the transport layer, which slaps on the port numbers. Think of this like adding a specific department, attention web server, to the building address. After that, the network layer adds the big one, the global IP address. And then finally, the data link layer adds a local address, the MAC address, which basically just tells the network how to get to the very next stop on the journey. It's like telling the mail carrier which street corner to turn at next.
And this whole packing process, it actually has a technical name. It's called encapsulation. It's really just a fancy word for wrapping that original data up in all these different layers of info, with each layer getting it ready for the next part of its trip.
All right, so our package is all packed up, it's addressed. Now what? What road does it actually travel on? Well, let's take a look at the very real, physical highways of the internet. Believe it or not, the internet's highways are mostly built from two main things. You've got your traditional copper cables, which send data as little electrical zaps. And then you have fiber optic cables, which use pulses of light. Now, fiber is way more expensive, but it is absolutely perfect for those long-haul journeys, because it's pretty much immune to any kind of interference. And of course, we can't forget about the roads that aren't roads at all. I'm talking about Wi-Fi. It just sends our data package flying through the air using radio waves. It's what connects all our devices when, plugging in a cable just isn't going to happen. Okay, so we've got the package, we've got the road, but how does the package know which turns to take to actually get where it's going? That's where navigating the map comes in. We're diving into the global postal system of digital addresses. There's a quote from the source material that just puts this perfectly. It says that just like your house needs an address for the mail to find you, every single device on a network needs an address so data can find it. Simple as that. Now here's where it gets interesting. To make this journey happen, every device actually uses two different addresses. First, you have the MAC address. Think of this as the who. It's a permanent ID baked right into the hardware. It's only used for talking to other devices on the same local network. But then you have the IP address. That's the where. It's the address used to send data all the way across the world. So remember, MAC is for local chats, IP is for global delivery. Okay, but wait a second. How does a device look at a string of numbers, that IP address, and know which part is the street and which part is the house number? Well, that's where something called the subnet mask comes in. It's basically a filter that separates the network part of the address from the device part.
Let me show you how it works. Let's say you've got an IP address, like 172.16.0.1. The subnet mask is what tells the device, hey, that first chunk, the 172.16.0, that's the street you're on. And that last little bit, the .1, well, that's the specific house number on that street. See? Pretty simple and really effective.
So our little data package has traveled the highways, it's navigated the map, and it's finally arrived at its destination. So let's look at what happens now, the unpacking process, and really get into why this whole layered system is, frankly, kind of genius. It's pretty much what you'd expect. Just like we packed the data, the arrival process just unpacks it, but in reverse. Each layer takes a look, checks its own address, unwraps its specific label, and then passes the package up to the next layer in the chain, all the way until that original data request finally gets to the web server. So you might be thinking, why go through all this trouble? Why all this complexity? One word, scale. I mean, just look at this number.
A single Class A network, which was one of the internet's early building blocks, was designed from the get-go to support over 16 million devices. The entire system was built for absolutely massive global growth.
And this right here is the crucial point. This is the big takeaway. This whole layered system, it's the secret sauce. It is exactly what allows your device, maybe on a kind of slow copper connection at home, to talk perfectly with a server that's on a blazing fast fiber connection halfway across the world. Different speeds, different cables, it doesn't matter. The layers make it all work together seamlessly.
And the real genius of it is this. Each layer has one specific job, and it doesn't care about the other layer's jobs. So the bottom layer, it just handles the physical signal. It has no idea what a web page even is. And the top layer, the one handling the web page, it couldn't care less if that signal is traveling over copper or a beam of light. This separation of duties is what makes the whole internet so incredibly flexible and tough. And in the end, all of this incredible, mind-bending complexity, it's all designed to be completely invisible to us, just like the source material says. As long as we can browse the net or get our work done, we're usually happy. We don't need to know about all the magic happening behind the curtain. So hopefully, the next time you click a link, you'll have a little picture in your head of the secret journey your data is taking. This hidden, layered architecture connects billions of us every single second. And it really makes you wonder, doesn't it? As our data gets more and more complex, what's the next great journey it's going to take? What new layers will we need to build for the future? Something to think about. Thanks so much for joining me.